Hey guys, and welcome back to the second video of this week's DearPiggy Basic Algorithms in Java tutorial. So in this video, like I promised, we're going to code up two pieces of code actually. One of them is going to be the nested for loops idea that I was talking about. Now, I'm not encouraging you guys to use this part. I just feel like more people would think of this idea first because this is usually your go-to thought to use. And then we're going to kind of see why as numbers get bigger, things could get messy. And then we're going to introduce our two-pointer function. Now, the two-pointer function is a little shorter than a lot of the things we've done before, which is why I think we'll have sufficient time to do this. So let's go ahead and jump right in. Last time we talked about our nested for loops. So this time I want to show you a code example. So we'll go ahead and type this up in a little while, but we have two for loops here. Now, since we have two pointers, right, in the end, we're going to want two values. So if we completely forget about our two-pointer technique right now, we're looking for two values added together that will give us the target value of 11. One for loop isn't going to cut it because we have two values that we need to find. So we put one for loop with the integer I, and then we stick another for loop inside of it with the integer j. Now, inside of these two for loops, so the first for loop is going to start from 0, so the very first. It's going to keep on going until the very last index, and it's going to increment each time. The second for loop, it's going to be, you're going to start from the very last value. So we don't start from 0 and 1, we start from 0 and as far as you could possibly go. Now, the reason why this is array length minus 1 is because array length is going to give you a number that is out of bounds. And since we're using indexes, we have to subtract 1 to make it in bounds. J always at all times has to be greater than the index 0 because we don't need to go back to where our I originally started. And then J is going to decrease each time because, as you know, I is moving up, J is moving down, right? So that's the two ideas of the for loop. And if the I plus J is equal to our target value, we're going to print out those two values. There are a couple problems that could happen. Let's go ahead and type this up really quickly. First is the runtime that I talked to you guys about last time. Time complexity is something that we haven't talked much before, but as we get deeper and deeper into algorithms, I feel like it's important to bring up what time complexity is. And so time complexity is how many times the code will have to run in the innermost loop. Now, in the innermost loop right now is, I guess, this if statement / the for loop. So in the very deepest part of your code, how many times will the program have to run? And in that case, we're going to see that our program is going to have to run n squared times because a nested for loop means you're squaring whatever you're running. So the time complexity is called, we write this in big O notation, which we will get into probably in a more advanced course. The time complexity is going to be O of n squared. So I don't want to get too deep into that right now. I just want to bring it out to you that we have a time complexity of something squared. And I want you to keep that in your minds right now and store it. So let's go ahead and write that code really quickly. First thing we want to do is we want to create our integer array. So int array is equal to, what numbers do we use? I want to use the same numbers so that we know what we're doing wrong. 1, 3, 4, 8, and 9. If anything goes wrong, we can double check. 1, 3, 4, 8, and 9. And so we also need to give it a target value. What is the value that we want to reach? What is the number of cookies that Mrs. Smith wants to purchase? And we want to put these two together using our batches, right? So our target value is 11. We know right now that the only way to make 11 is the 3 and the 8. So put that in your head. That way, when we run it, we can see what goes wrong, if anything goes wrong. First for loop, int I is equal to 0. It's going to start at the very left side. I has to be less than the length of the array, and I is going to increment each time. Now we also need our second number, so we're going to say for int j, but int j is going to start at the very, very right side of our array, all the way at 9 over here. So I, though, 0, 1, 2, 3, 4, 9 is at our 4th index. However, when we asked for array.length, whoa, I did not mean to write that there. When we write array.length, that technically gives us 5, and there's no 5 index here, so we'd have to subtract 1. J always has to be greater than 0. We will never want it to equal 0, and have J subtract each time it comes through. Because, like I said again, I moves up, J moves down in our little thought process there that I explained in the last video. Now we only have one part left. If the array value of J, or we can start with I, plus the array value of J is equal to the target, then we can print out the two values. System.out.println, ARRI, and then a space, and then ARRJ. So what have I done here? Simple piece of code, probably possibly even simpler than our 2-pointer, but it is in no way that fast. So let's explain really quickly. Actually, I should get rid of this space because there's no point for it. All right. We had everything set up until here. I explained it. Then we said that the value of array at I, keep in mind that I is an index, so you cannot add I plus J because those are going to be 0, 1, 2, 3, 4, 0, 1, 2, 4, 3, 2, 1. So you can't add I and J. That is very, very important to remember. It will also come up in the next part when we use our while loop. And then we use the array over here, array get I, which gives us the specific value, whether it's 1, 3, 4, 8, or 9. And as long as it's equal to the target, we're going to print out what I and J are in terms of the values. So let's run the code. It should give us 3 and 8, but we're going to see that it actually gives us two things. It's going to give us, let's give it a second to run. It's going to give us 3 and 8 and 8 and 3. Now that itself, you're going to see is a problem because that is a duplicate, right? 3, 8, 8, 3. We both know they both get 11. It both meant the same thing, but it both printed out twice. So in our very basic nested for loop here, not only is the time complexity something squared, n squared, which is going to be a lot, it also doesn't give us the best answer we want, right? Keep in mind, if the array length was close to 1,000,000, then you would get 1,000,000 times 1,000,000 squared, which is something so big, I don't even want to imagine it. And so our code would crash, right? So this is the for loop that most people will choose to take when they see this question. And that is the naive approach that unfortunately lots of us are going to be doing. This is the 2-pointer part. So for now, I'm going to actually create a new REPL because I feel like we can compare these later on, but we're going to create a function that is going to set up our 2-pointers for us because functions are just amazing and wonderful. So in our function, we're going to take in two parameters. We're going to take in an array and a target value. Now this is no different than our code here. In our code here, we just did everything in our main function and we created an array and a target value. All we're going to do in our next piece of code is we're going to pass in those two values there so that we don't even have to create an integer target. We can pass it in, and we don't even have to create an array. We can pass it in as well. So the function goes here, public, we're returning an integer array. You're going to see why in a second, to sum, and we're going to pass in an int array here and a target value. So those are just their parameters. Everything should look correct, right? Pass in an array, pass in a target value. And first things first, which is super important, you must sort the array. It is so, so important because we need the values to be from least to greatest so that we know that when we're too big over the target value or too little, we know exactly which way to move. So we do arrays.sort ARR. Simple as that. Let me go ahead and import java.util.star just to make sure we don't get any unnecessary red lines that will bother us. So once we've sorted the array, this is where we set up the pointers. So our first pointer is going to be our left pointer, and our left pointer, I guess we can say int left is equal to 0, int right. Now is int right going to be a tangible number? No, because keep in mind that we're using indexes and we don't know how many indexes our array is going to have. The 0th index is always the first number, and so the other index, since we want to keep it in bounds, we're going to do the length of the array minus 1. So that's going to be the very, very last number at the very right, or the biggest number in our array, right? So now that we've done this, we've set up everything that we need to do in our function. The next part is to, I guess, write the meat of the function, right? This is where we're going to be doing the actual part where we're using our 2 pointers. So let's go ahead and jump right in. I'm really excited for this, actually. Let me hide the floating Zoom meeting controls and I'll show you this. So while left is less than right, why do we say this? And can anybody remind me what left and right is? Well, left and right, keep in mind, are your 2 pointers, and we never want the left to go over the right, because then there would be no point of our pointers anymore, right? The whole point is that we find something that works before they cross over each other. So when this is no longer true, our while loop will stop. And here, an if statement inside of a while loop is not considered nested. Nothing is considered nested unless you have 2 of the same thing inside each other. You can have as many as you want parallel. And in this case, we're going to be using if statement, else if statement, and else statement all parallel to one another. Nothing is nested. And we'll see why this is important in a second. So if our optimal solution, our optimal case, when the value of your array at left plus the value of your array at the right is going to be equal to the target, that is perfect, then you're going to return a new int array with your left and right values. So left, right. This part confuses some people, but it's honestly, guys, not that confusing. All it is I'm creating a new integer array, remember, because we're going to end up as the return type with an integer array. And there's going to be 2 values in that integer array, the left pointer value and the right pointer value. So that is our best, most optimal solution. There are also, most of the times, we won't get our most optimal solution. So let's pretend that the array left value plus the array right value is greater than our target value, which could happen, right? So what does it mean when the 2 pointer values added together is greater than our target? Well, that means since we know that array is sorted with the bigger numbers at the end, that means our thing needs to go smaller. And so to make things smaller, we want to move our right pointer near the bigger end over. We want to move it over 1 to make our overall number smaller. So we're going to say right minus minus, because the right is an index. Minus minus means minus 1, and so we move it over 1 to the left. The last case that we have here, which we don't even need to specify because the only other case that could possibly happen is where it's less than the target, and then when the value is less than the target, we want to make it bigger. So we would move our left pointer, which is with the smaller values, up and over 1 to make it bigger. So you'd go left plus plus. Now let's take a look at, what happened to our red lines? Let me look at our red lines really quickly and see what happened. It says we have a misplaced token. Guys, what happened here? I forgot my if. We're supposed to have else if. I just only wrote else. No wonder Rebel was mad at me. I thought it was being mad at me for no reason again. Okay, so let's talk about what we've done here. This is essentially the meat of it. We are done with the meat of it, besides one very, very important line. We've said that this is all under the assumption that our values, our pointers, have not intersected yet, because we don't ever want those to intersect. If the 2 pointer values added together meets the target, give us the 2 values that are correct. If the left and the right pointers are greater than the target, move the right pointer down 1 or subtract 1, so move it to the left one. In the other case, the last case that's left, where the right and left pointers add to less than the target, meaning we need to make the value bigger, we'd move the left up 1 or add 1 to the index. that is what it says here. We've also forgotten one very, very important thing, is that in these cases, after our entire while loop is done, no matter what, we also need to return something, right? We need to return the final value because this doesn't happen all at once immediately. So after we finish running our while loop, we need to return our final answer at the end. So we're going to return a new integer array. Basically, we're going to take this line and copy paste it, is what I'm saying. So let me go ahead and copy paste this code. Paste. There we go. All right, so the function is complete. We have finished it, and now we have to run it. Everything, remember, once you make a function, you have to make sure to run it. And so, does everybody see how the answer is going to be an integer array? So it means we're going to have to set an integer array called result and set it equal to the function. And we need to pass in an integer array and a target number. I'm just going to create an integer array right inside of this function. So new int array with the values, what values we used. Remember, we want to use the same values there. I forgot to show you this slide, but this is what we're doing next. We're going to create the values with 1, 3, 4, 8, and 9. So 1, 3, 4, 8, and 9. And then we have to give it one more value, the target value, and we're going to use 11 like we have always been doing. So let me bring this out a little bit so you can see the full thing. Last but not least, when we run this code, nothing is going to happen because we just have a result array that saves the two numbers. So we're going to system.out.println result 0 plus a space plus result 1. Now remember, since result is a fixed array that will always have two values, we are going to only have to print out the 0th index and the first index because we are using 2 pointers. We're only looking for 2 numbers. Let's run our code and make sure it works. So I run my code and I see that we get 3 and 8. Now we also see that we got the same answer in our for loop. And while, again, I mentioned this does look easier, it really does. But the time complexity here is O of n squared, whereas the time complexity over here is O of n. And so a constant number will always be less than a number squared. So we know that this code running is going to be so much faster than this code that we wrote over here when it comes time to use huge numbers. Also, this doesn't give us repeat answers. We only get 3 and 8. Okay, so this video has taken a rather long time, longer than I thought. If you have time, go back and watch again the parts that you don't understand. But otherwise, I hope you guys understood that. And I hope you guys enjoyed this week's videos. I had a blast making it, and I will see you guys back in 2 weeks. 2 semanas, 2 weeks. We're taking a break next week. Bye, guys.